Thank you so much. It's my pleasure to be here today to tell you about our research program in psychology, cognitive science, and artificial intelligence. My work is in collaboration with the team at Stanford University. Hari Subramoniam, in particular, is a lead. He's in computer science and education. Roy P. and Christopher Pundak and Manish Agrawal. And I have been working on this project and also working with a team here at Michigan to tackle the problem of what does it mean to have joint human-AI intelligence? What does a combination of human and artificial mind mean, and how do we achieve that? So I'm going to ask you to take a different frame of reference about the problem of AI for the next 20 minutes, to think about, instead of thinking about what can AI do, many of us have leaped into that breach and come up with amazing things that AI can do. But my question for you today is, what can humans do? What can humans do using AI, and how do we think about human cognition in the context of the AI tools that we now provide? So I started with artificial intelligence in the 80s at Yale University. And there, our dream was to someday have the natural language capacities that we now have at our fingertips. We couldn't imagine the success that would come after many years of contributions from people like David Rumelhart in psychology, who came up with the back propagation algorithm. So many important ideas along the way in this intersection of cognitive science and artificial intelligence. But when we look at the idea of natural language in terms of how we're using it, we, in a way, have such an amazing tool in front of us that we haven't really looked at what that tool is. So in the case of natural language, when we think about how we interact with other humans, the main advantage of natural language is that we understand the meaning behind it. We get the gist, we get the intended meaning quickly. And we have theory of mind. That's a concept from psychology, our colleague Henry Wellman here in Michigan. The idea that we not only track what we know, but we track what the other person knows and what they think and what a third party might think. So we actually have frames of reference to interpret meaning based on what we know they know and what we know they don't know. So understanding the meaning of what someone's saying isn't so simple as looking it up in a dictionary, even though that's an amazing dictionary. But the meaning depends on the context, including the context of the other person's mind. And a third important point is that humans constantly negotiate the meaning of information that they get in natural language. So I can ask you, did you mean this? Or what if you add that? We're constantly trying to ascertain that we share the same meaning. We are on the same page. We are aligned in understanding that meaning. When we look at how it's available to us in natural language processing and AIs, though, we see a different approach to natural language. So there we have amazing power. It's not meant to be negative about natural language and AI at all. But we have an AI that's intentionally sensitive to how you express something linguistically. So in human language, you'd say the power is, I can ask you to turn off the lights in a million different ways and you'll understand what I mean and turn them off. But for an AI, it actually is important how you use it. Which words will access different words depending on how you express it. And that's different than how people's natural language works. It also lacks any theory of mind about the user. So an individual or what people in general think or what people in your community think, it's not modeling those differences in understanding that is really, in my opinion, what you get out of college, like understanding what things mean to other people and why they mean different things. And finally, the interactions are static. They don't build or exchange in a way that contribute to a shared meaning that didn't exist before. So the cycle of entering a prompt, getting a response back is amazing and terrific. but you may have to do that repeatedly to reach information. So the point I'm going to push you on today is the idea that with AI and natural language interfaces, you can do anything. That's the promise. Like, there you are, ChatGPT is open in front of you. It can understand anything you say. That revolution is unprecedented. It's so powerful. Think back on maybe the first time, if you're an older person like myself, the first time you used a computer interface, it probably had a few buttons or a menu or a short list of what you could ask it to do. Now you can ask it anything. That is so powerful. But the problem is you can't ask it everything. You can't ask it to do everything. So let me go through some of our reasoning about this and why we have this vision for a different approach to how we're studying artificial intelligence. So, like many of us, you may be called upon to give a toast. And say at a wedding for your friend Taylor. So you go to ChatGPT and you say, help me write a short toast for a wedding. And it happily generates a toast here on the left that's very similar to other toasts you've heard before because it's based on a library of having read a bunch of toasts and recognizing similar words in wedding. And you take a look at that and you think, no. So what I meant was, how about write a short, funny, and creative wedding toast with just 3 sentences? So now you repeat again, the ChatGPT comes back, it's got another story, but it says, I can try to help you. Like, what are you trying to do here? Do you want me what do you want me to say in the toast? Here's some suggestions. This is the information I need. Gives you 5 questions that you need to answer so that the ChatGPT can build you a better toast that meets your needs. And as you're starting to type these things in, you might be thinking, this is kind of a lot of work, maybe even more work than I would have done to write it myself. But okay, here's some information. We go along, we get a response. Okay, here's toast. It combines the information I have and produces a repetition of the idea of pigeon. So maybe not my choice. So thanks to natural language, I can just say, lose the pigeons, and it will do it again and come back with a response that avoids the information I want to omit. So you can imagine that this might take me a while to figure out what I really want to say. What do I really want to say in the toast? And if I say that I want something that's funny, how does the AI understand what I mean by funny, or what do I mean by funny? It's different than what you might mean. So as you proceed through this kind of exercise, you may get the sense that prompt-based interactions can be kind of annoying. It can take a long time to go through these iterative cycles of, here's the whole thing I want. It produces a whole result. I evaluate it and say, how close is that to what I intended? And then I rewrite the prompt and start over and generate another complete response. So while this is an amazing power, don't get me wrong, there's something kind of missing here. We haven't tried at all to figure out what the human does want and what they hope to get, what they hope to evaluate at the end. How are they going to know that you've done a good job with the prompt you're generating? We've put all the money on the natural language interface. You can ask it anything. But as the user, what do I ask it? What can I say that would make a really good wedding toast? I can't even think of examples I've heard, although I've heard many of them. So for the human user with a goal that they want to satisfy, it's not so straightforward how to tell it what you want. It seems straightforward because you can say anything, but how do you say the thing that you actually want to get out of it? Let me give you an example that's more meaty. When you're trying to generate code, this is from a student trying to generate code for a prompt that they want to take into their software. So they want to come up with, they're writing an explorable explanation, and they're using the analogy of a backpack, and they want to illustrate that with a backpack. So they give their suggestion, what they want, and then they get a response. I've generated that, And then the student answers back, okay, improve the readability and add the backpack. It answers, I've done that. I've changed the font sizes and added a backpack image. And the student answers, honey, there is no bag. So this is great. Like, you can express emotionally your response to the prompts, the results of the prompts. And then the AI answers, I see the issue. The backpack might not be displaying. Let me update it. Okay, I've updated it. Now you say, well, as far as the placement of the bag, move the boxes and the text too far away, bring them closer together, very explicit directions about spatial location. And then the response goes on from there. So there's quite a lengthy back and forth. And this illustrates that even though it's a technical task to generate code, and even though the person has a clear idea of what is satisfactory, like in terms of spatial relations, in terms of size, it's still not at all trivial to explain to another person what it is you want, let alone to another AI, right? So with the power of natural language, you also introduce a lot of problems, like the lack of specificity in reference, the lack of co-sharing, the intermediate work products. It leads to a lot of iteration, a lot of specification, response, and evaluation, and then iteration to repeat the task again. So for this task, which just was to write code to generate a backpack, how many prompts do you think it would take to generate that task? Well, for the student, it took 34. Okay, so you can say, that is really amazing, and it is, because AI did something for them that maybe they didn't even know how to write the code, but it did it for them, so that's amazing. But do you think they're going to be eager to do it again? How much do you think, in your experience and other people's experiences, how much are they getting right to what they want from the AI versus spending a lot of time not just getting the AI to what they want, but also figuring out what they want? Maybe they don't realize the spatial relationships until they see it in front of them and what the AI produces. So this is to illustrate that there are a lot of changes that go on, even though the tool is all-powerful, the interface is all-powerful, anything you want, yet to tell it what I want is not so easy. Here's another example. It comes from Jason Allen, who created this artwork using Midjourney, a Gen AI system. It won the first prize at the Colorado State Fair, the fine arts competition. And he wrote about having a literal vision of women in Victorian dresses wearing space helmets. He was halfway between awake and dreaming, and he said, oh, I've never seen or thought of something like this. I'm going to put it into Midjourney and recreate the image I had in my dream. Like, this is what we dreamed of with AI, right? And you see the image is quite striking. It won this art award. How many iterations do you think that this artist had to do to create this specific image? It was in his mind. And to get it on the page using the AI that could interact in natural language, how many iterations do you think it took? 624. So maybe we should expect this. You know, we know with working with human collaborative teams, you can go a lot of wrong ways in communicating in natural language. You require a lot of correction and reestablishing meaning. You know, maybe that's how it goes in actual human collaborations. But in this human AI collaboration, it was very effortful, even though there's a natural language interface and the computer can do anything. So maybe what we should be looking at is a way to interact with AI systems that's not playing 20 questions. It's not trying to guess at what we want. It's not trying to guess at how to tell the system what we want. And the system's not trying to guess what it is that we want. So maybe there's a way to think about whether the best interaction between the human and the AI is not anything goes, but that it's geared and structured towards how people think, and the AI knowing that so they can collaborate together. So the questions that we're looking at are, why are these natural languages interactions so challenging for people? What do people need to know to instruct an LLM? And how can we design LLMs to preserve human agency in thinking, so they still bring their idea, their question, their curiosity to the AI, and the AI partners with them to create something new? So given my background in psychology and cognitive science, we go back to, well, what do people do anytime they want to do a task? And this is a very simple model. It comes from Don Norman about basically how do we structure interaction with the world to achieve some purpose. So we have a goal, any kind of goal. We create an intention. So I want to make a toast. Then our intention is to be really funny, say. Then we specify the actions. To be funny, I'm going to have to tell a joke, but I'm going to have to not cross the line. And then we execute it. We write the sentences that produce the joke. Then we go into the world and we do it. We execute what we planned, and we get feedback. So we have to first perceive what came out of the world, and what can we interpret, how do we interpret that information, and how do we evaluate it. So in a software system, software takes the place of the world. We have the same sequence of events, but now the software is doing the work of the world. It's providing the feedback, the output of our actions, and we're evaluating its output. The reason this works at all is because with most software, we have a mental model. We have a system model that helps us predict what it's going to do. So we know that we should tell TurboTax, all of our receipts. We don't have to depend on it to ask us that. We know that about it. But with these AI models, we don't have any specification of what it does, how it does it, what might help it. Would it help it if I gave examples of toasts? Would it help it if I gave examples of jokes? Like, what is it that would help the AI perform more like what I want? That's missing in LLMs. So we have no mental model of how they work. Even the people that build them have no mental model of that. We have no action specified, so we don't know what the cognitive steps are in the AI's process to produce the results, and we don't know how it executes at all. So that means in terms of helping the AI reach what we want, we're relying solely on intention. It's intention that we try to specify in the prompt, and only intention can drive the outcome. Intentions in people are linked to situations, specific contexts. They include knowledge of all kinds, decisions, skills, and they're in a complex hierarchical structure. And most importantly, they only emerge during process. So you don't really know what story you're writing until you started writing it. Then things that are important to the process come up. So that makes this process of intention being critical to use of AI. We're calling this process envisioning. So before you start a task with an AI, you need to be thinking about, what do I envision as the process and the output of my intention? What will satisfy it? And that includes planning and executing, mentally simulating what would lead to good success, and specifying ahead of time what you think you want. That's very challenging, and it leads to kind of a gulf, because again, we can know what we want, but we don't know how the AI is going to fulfill it, so we can't give you any hints about how to do it or what will make it a very appealing output. So this distance between what the human intends and the instructions that the LLM actually executes to produce it is a terrible gap in identifying a one-pass solution that we might be happy with. So what we learned from this work is how important it is to partner with the AI, not just on the first pass of what to do, but also the intermediate steps in its doing it. We need to be able to touch base with the AI as it's making decisions about its solution path. We need to be able to have a language that between the AI and the human, so the AI understands why and what the user is thinking about what they want, and can provide information to the user along the way as they approach a solution. So this kind of interactive process is going to be the key, we think, in the next stages of building AI that really can do everything. Thank you.
just jumped up to the top of the list here. I'll pick that one and then two of those. Thinking of text-based tasks, LLMs seem to move us away from being writers and towards being editors. Does this have implications for how we credit authorship and the ownership of those created works?
Yeah, so some really exciting research has been coming out about how people feel about the ownership of their AI-produced masterpieces. And what we find is, along with in my own research on creativity, if you didn't personally think of it, you don't think of it as your idea. So if you use a creative tool, like a card that tells you to think in a certain way, you think, I'm not responsible for that because that wasn't my process, that wasn't the way I generated the work. So people feel less ownership of ideas when they use a tool to help them execute something that's usually entirely internally done mentally. So you're seeing the same thing with AI use, that people, even though they write an incredible prompt that produces a story nobody's written before, they feel like it's not their story because they didn't execute it. So part of this idea of envisioning is to say, what does that involve? Like, what are you contributing to the AI, and what is it contributing to you? And if you can identify it's an execution step, then you might have a different view of ownership than it's also in the envisioning stage.
All right, let's thank the professor one more time.
Hello, everyone. This is Heonuk. I'm a postdoc research associate at ISR. Also, I'm an AI fellow at the Midas. This is a co-work project with Dan Schiff at Purdue University. So thank you for giving me this great opportunity. So since this is a research vision talk, I want to briefly talk about what I'm doing as a social science researcher. Whenever I go to this kind of the AI conference, I mean, many scientists and computer science people, oftentimes they ask me what I'm doing. So I want to briefly talk about what we are doing, in public policy or political science and public administration. First, we study about AI policy. So based on the institutional framework, personal attribute, and broader governance components, what kind of national strategy, regulatory instrument, and funding schemes are enacted in the government. For example, one of my research compared the president executive order by Trump and Biden. So maybe based on their different party ideology, the Biden in the kind of the executive order, he talked a lot about the values, DEI, and the safe use. But Trump, he just eliminated ideology, language, and more focus on the innovation. And also, in the past couple 6-7 years, there were over 150 rules were made by the federal agencies on AI use. So this is kind of our broad research on AI policy, and also what are the the political and economic drivers of AI adoption, not only in the federal but also in state and local. In addition to that, the governments and private sector, they have been widely adopting AI. What's the effect in the society, governance, and administrative performance? They mainly aim to improve effectiveness and efficiency, but how much it really has the impact. And also the perception of the citizen and public officials, especially the core values in the democracy, can be a really interesting topic for us. And also, at the same time, we use various models on AI and machine learning for as our research tool. So, we conduct text analysis, geospatial modeling, and also predictive analysis and causal machine learning. So, as a method, we also use AI and machine learning for the research. So, but today I want to talk about the measurement, how we can compare the readiness of AI at the country level in the past couple of years. So I have several motivations. So AI, has been reshaped our industry, government, and our everyday life. Oftentimes, public policy plays a critical role in this kind of the emerging area in industry. So especially in AI has been emerged a lot in past couple of years. So each country's government, they have been enacting different public policies, like regulation or deregulation, and different funding strategy and public-private partnership. But different intensities and different focus by country, eventually it produces different outcomes. So as a social scientist, measuring AI capacity is critical for the effective governance and also to contribute in social science. Thankfully, in the past couple of years, multiple organizations produce AI governance indices. However, sometimes their focus, scope, scales are very different from each other. So based on this, our research question is, how can we conceptualize and measure the state's capacity to govern AI in the digital era? So this is the brief overview. So we want to first compare and assess 7 global AI governance indices. And then we want to extend traditional policy capacity theory by integrating innovation and ethical aspect. After that, we conduct factor analysis, mainly to EFA and CFA from the data for 101 countries in 2023 and 24. So we want to extract the latent components. So, for those who are not very familiar with the policy capacity theory, in the theory, there are 3 big components in the policy capacity. The first one is the political capacity. So the legitimacy, trust, and coalition support necessary to sustain governance. And also operational capacity means, to coordinate or mobilize resources for effective implementation. And also analytic capacity is also very important to access, generate, and apply expert knowledge. But this is very traditional policy capacity theory that can be applied in any policy area. But when you think about the AI governance, we think we need to modify these capacities a little bit. So responsible AI governance. So many people talk about the ethical issues and potential risk. So we think, we should focus on the normative legitimacy, right-based legal framework, transparency, and ethical oversight. How well each country is prepared for this. And technical and operational capacity in AI governance, we think digital infrastructure, data system skills, institutional readiness for AI development. And also the previous one, they mainly focus on the governance side. But in the AI governance, we think the research from the academia and private sector, their role is also very important. So we included innovation and investment readiness, which means the ability to cultivate AI innovation, the talent, research, R&D, and commercialization. So based on these 3 subcategories, we want to create the measures, and we want to compare the countries who are doing well, and if one country is continuously doing better or worse in different years. So these are there are many kind of the institutions and indices measuring about AI governance. I want to highlight some of them. The first one is the Tortoise Global AI Index. So this is the global media company. They mainly focus on the implementation, innovation, and investment. So they mainly use 122 indicators from from over 20 sources. And also Oxford's AI readiness is they cover broad number of countries, and their main focus is government, tech sector, and data infrastructure. And Center for AI and Digital Policy, they mainly focus about the ethical part, if they follow the rules on the international organization, if they have the bills dealing with the ethical part. And Stanford High Index is one of the most widely used index in the past 7-8 years. They have a very sub-level indicators, but their limitation is they only cover 36 countries. So we have 3 more indicators, but for some data set we couldn't get from their website, so we asked individually and got some indices in the broad sets. So based on the data set we have, we first construct a consolidated data set covering all countries and indicators. After then, we standardized variables and rescaled to a common 1 to 0. And then we captured the dimension, so many different kinds of the dimensions. And then there are, of course, the missing parts and missing countries. So if there are, the countries missing, across all years and variables, and we exclude it. Otherwise, we use PMM imputation to calculate to fill the missing parts. And then we conduct two vector analysis, EFA and CFA. I want to talk more about this method later. So these are the three the domains we want to argue. And the EFA is we want to calculate the latent dimensions. Just we want to see the data structure. So for each domain, we put 15 to 20 indicators, and computer itself calculated which domain, which variable is included under what domain. And CFA, we designate 6 to 7 variables for each topic. After then, they calculate the correlation. So this is our research design roadmap. So based on the source, we create the data set and conduct the vector analysis, and then we got the vector scores. So for the EFA, so we, first thing we should consider is how many vectors we want to use. So we conduct parallel analysis, and across all three domain, we think maybe the two vectors per domain is ideal. And under the responsible AI governance, based on the EFA, the computer captures the ethical and transparent AI governance, and responsible AI governance capacities could be the main topic. And there are a list of the high loading indicators from different institutes. And this is the public sector AI readiness, which is about technical and operation. So there are two main factors: the government operation readiness and infrastructure and innovation capacity. And this is the kind of the loading score for each variables used for the analysis. And AI innovation and ecosystem, also we conduct the same EFA, and AI innovation capacity and AI research and develop. These are two main factors in this domain. So CFA is different from EFA. So we designate, based on each theory, we put 6 to 7 indicators per topic, and then the computer calculated the loadings and correlations. And then this is the loading scores. And this is the key variables for each topic. And in terms of the model fit, this is, it's good enough, but some measures it's not high enough. But this is common in the comparative research. And also there is a kind of the correlation between the innovation and the others. So which is, maybe, one country is doing well with the innovation. They are also doing well with other aspects. So so this is kind of descriptive paper. So if you guys know more about, the entire data set and the process, I'm happy to share the paper. But, there are some contributions. So effective AI governance, it relies on the combination of the regulatory, technical, and innovation capacity. And also empirical factors translate broad policy capacity concepts into concrete, measurable, and measurable dimensions. And also, in addition to the theory and method contribution, I think this score will be very useful for the practitioners, if there are practitioners here. So it diagnoses the capacity gaps and across the country, and also we can compare, if one country is doing well for innovation but lack in the kind of the ethical or governance part. So this kind of the new score created by, created by the fact analysis can give some analysis for the practitioners. And for the future research, since, I think the missingness was kind of the big issue, so we want to recalculate, we want to try something, some more. So we want to calculate, maybe OECD country or regional subsets. And also we want to expand the panels to the earlier years. And then we want to, keep moving on the year after. And then probably in the long-term agenda, we want to integrate text analysis of AI strategies and policy documents. And also we want to, based on, we plan to use, this one as a dependent variable or independent variable. And then we can conduct, follow-up social science research, based on this innovation score. Are they doing well in the kind of the performance-wise or, something else? So, so this is about our research. Okay, thank you for listening. And
great, thank you, Dr. We have time for at least one, maybe two questions. Can you share your expert perspectives and insights regarding how the U.S. compares to Europe in terms of AI governance? What are some of the strengths and differences there?
Okay, it's a big question, and it really depends. I like numbers, so in kind of all 7 indicators and kind of different measures. I wanted to check where the U.S. is and how much is the gap with China, maybe in different domains, innovation, but. In terms of, it's too broad, but in the subcategories, USA is mostly, on the top, and the gap is, huge, even compared to, second and third. But in the kind of the nation, in the time trend, the gap is decreasing, especially, US and China. But still, the other, Europeans or some other, emerging countries, their kind of the rankings are very low. But it really depends on the, which aspects you want to ask. The innovation, regulation, and operation, government policy, it's really different. So if you guys want to know more details about, the rankings or the gaps, I'm happy to share the paper and maybe the data set itself. Yeah.
Great. Okay, let's conclude with one more question. Are there metrics for determining the accuracy and quality of information used by the government to make decisions? How might such metrics be used to encourage evidence-based governance?
Okay, so governance is too broad. I think the governments. I went to conference last week. People asked me about what kind of models can be used in different types of use. So maybe clustering and regression and maybe neuron. You can apply different types of AI and machine learning models and based on the types of use, and then we can measure. You can use different measures for errors and accuracy. So this is too broad. But maybe if you give me, a specific example later, maybe I can answer better. But we are still, social scientists, we are still thinking about which method can be used and which data set can be best used for, different types of, AI use in the public sector. Yeah.
Right. I think it might have been related to that question, might probably be getting at how there's a tendency for some governments to kind of make up information or bend information to justify what they're going to do anyway. So it's kind of interesting to think about, is there some way AI can help give some information to the public about the quality of the information? It is a pretty broad question, so I understand. Well, let's thank Dr. Ha again